A stone is thrown with a speed of 20 meters per second, once at an angle of theta degree and then at an angle of 90 minus theta degree with the horizontal. It is found that the difference between the maximum heights attained by the stone in the two cases is 4 meters. What are the maximum heights in each case? Yes. Suppose you throw a projectile at an angle theta to the horizontal, like this. It follows a parabolic path. And if this is the initial velocity direction, and if this is the angle made by the initial velocity direction with the horizontal, then h is the maximum height. We have a formula for the maximum height. H is equal to V naught squared sine squared theta naught by 2g. Now, here it is thrown initially at an angle theta and then at an angle of 90 minus theta. So when I substitute here, I can put this sine squared theta naught as sine theta naught whole square. So I can write it like this, whole square. So when I substitute sine 90 minus theta naught, I will get cos theta naught. That's all. So sine 90 minus theta naught can be written as cos theta naught. So the second angle could be taken as cos theta naught. So if I write the formulas for the two cases, here we have two cases, so definitely we have to write the formula twice and you have to solve it. That is the main logic behind this problem. It is a comparison type. When the angle is theta, the maximum height is h. And when the angle is 90 minus theta, the maximum height is having a difference of 4 meters. That means if I take the first height as h, next height can be taken as h minus 4 or h plus 4. Anyway, you can take it in any way, you will get the same answer finally. We will check both. Now, for the first case, I'll write h is equal to V naught square. It is given 20 square sine squared theta naught. Okay, sine square theta naught by 2g. 2 into 10 I'll write because 10 it is given, acceleration due to gravity. So this comes to h is equal to, or we can take it as equation 1. Let it be equation 1. Now, second case, when you throw the same stone with the same velocity, but an angle of 90 minus theta naught, what you will get? So that makes a different height. When the angle is changed, the height, maximum height is different. And they say that the previous maximum height and the maximum height now, they have a difference of 4 meters. So I'll take this new height as h minus 4. And what will happen if I take it as h plus 4? You will get the same answers. Well, that makes no difference. We will check it. Now, h minus 4 is equal to same initial velocity square into sine 90 minus theta naught whole square. Sine squared theta we have by 2g. 2 into 20, 2 into 10. That implies h minus 4 equal to, so they make a difference of 4 meters. That means the final height and the initial height, if you subtract them, you will get a difference of 4 meters. So h minus 4 is equal to 400 cos squared theta naught by 20. This is equation 2. And if you want, you can write the equation 1 properly so that it becomes easy to divide them. So I'll write the equation 1 as equation 3. H is equal to 400 sine squared theta naught by 20. Now if you look into this equation, always remember, division is not the only solution for solving two equations. Sometimes addition becomes very easy. Because if you look into the equations here, you see here you have cos squared theta naught, and here you have sine squared theta naught. You know that sine squared theta plus cos squared theta is 1. So better you add them. So if I go for the solution like this, equation 2 plus equation 3, what you will get? H minus 4 plus h, left hand side. Here h minus 4, here h is equal to, and in both the right hand sides, you have 400 by 20, 20 times 400, 20 times. So you have 20 common. So I'll write 20 common into here cos squared theta and here sine squared theta. Cos squared theta naught plus sine squared theta naught 400 by 20, that is 20 is common in both. I have taken it outside because I am not dividing, I am adding. H minus 4 plus H in the left hand side is equal to 20 cos squared theta naught by, plus 20 sin squared theta naught, 20 common. So this is 1. You know that this answer is 1. So what you will get? 2H minus 4 is equal to 20. H is 2H is equal to 24. That implies H is equal to 12 meters. If H is 12 meters, then another one is H minus 4, that is equal to 8 meters. Because another is H minus 4. So 12 minus 8, 12 minus 4, that is so I better I write it like this. So another distance H dash I'll write. H dash is 12 minus 8, 12 minus 4. H dash is 12 minus 4, that is 8 meters. Now, instead of taking H minus 4 here, if I had taken H plus 4, what would have been the result? I'll take the third equation as it is, because I'll take the first one as the same, that is H is equal to 20 square sin square theta naught by 2g. So that comes to H is equal to 400 by 20, that is 20 into sin square theta naught. That is same equation. That is what we have written the third equation. 20. This is equation 1, I'll write. This is just verification. Problem is actually over. Now for the second one case, I'll write it is 4 meter more. H plus 4. Then I'll write H plus 4. This instead of H minus 4, it becomes H plus 4. And remaining thing is same, 20 cos squared theta naught. Now if you add the two equations, what will you get? 1 plus 2 gives. This need not be done in the exam. H plus 4 equal to 20 into sin squared theta naught plus cos squared theta naught, which is equal to 1. 2H plus 4 comes to 20. 2H is equal to 16, implies H is equal to 8. That means you will get this answer first, that's all. And the remaining one is 8 plus 4, the new H dash. Because H dash is 8 plus 4, that is 12. That's all. So you get this first and this next. That's the only difference. Thank you.